Okay, here they say, find the derivative. I would not use the definition of derivative to do that, and they didn't ask for that. I would just simply use the rules of differentiation. And to do that, I want to write it a little bit differently. And not that you have to, but I'm going to write this as x plus 4, and the top I'm going to write x to the 1/2 power. How do you differentiate that? Well, a couple of different things I have to do. Certainly I'm going to look at this as a quotient rule. So it's x plus 4. That's going to be squared. Bring x plus 4 to the top and leave it alone. Times the derivative of the top. Was that going to be 1/2 times x to the minus 1/2 plus the top, which is x to the 1/2, times root of the bottom. Well, root of the bottom, pretty simple, just 1. Now, someone says, is that it? A lot of teachers say that's it. That's the answer, they would say. And they would say, please leave it that way. But I'm going to say it looks really kind of bizarre to me. So what I'm going to do is I'm going to say that's not really an acceptable answer for a large number of teachers. What I'm going to do is multiply top and bottom by something. Let me write this down carefully. Whoops. I'm going to say carefully. I got to make sure I'm saying that carefully. And then x to the minus 1/2. And then plus x to the 1/2. What goes on bottom? X plus 4 squared. I'd multiply top and bottom by a rationalizing factor, and that would be x to the 1/2. X to the 1/2. In addition to that, I don't like the complex fraction there, so I'm going to multiply top and bottom by 2 as well. Let's put that down. What do you get on bottom? 2. X to the 1/2 is just root x, and then x plus 4 squared. If you did the top, though, and that's probably the challenging part, you're going to multiply that across. What do you get? Well, let's be careful. You get x plus 4. 1/2 times 2 disappears. And x to the minus 1/2 times x to the half is x to the 0, so the x disappears too. Let's keep going. Plus, what do you get there? Well, you're going to get 2x. You know what? I made a mistake. I just noticed it. And it's good to notice things as you're moving along. I was using, I said plus, but it's really not plus. But it's easy to erase things and correct them. Sorry about that. Now, it's the quotient rule. I made a mistake there. So let's keep going. What do you get here? On the bottom, you get 2 root x. And then you get x plus 4 squared. What do you get on top? 4 minus x. Let me put a little box in this, and let's just check the key. I want to check the key. I want to point out, you might be looking at this and saying it looks different. It's not different. It's the same thing. So I'm going to see the x plus 4. I see the 1/2. And by the way, x to the minus 1/2 is 1 over the square root of x. What's over here? Minus root x plus 1, and then x plus 4 is quantity squared. I multiply top and bottom by 2 root x. Same thing that's over here, by the way. And then I got this over here. Are we getting the same thing? Yes, we are. This over here. Now, I realize some students are going to say, oh, my teacher told me not to put roots in the bottom. And if you want, you can rewrite it. I just don't see it adding much to the problem. Let me go through that with you. So you could write down 4 minus x times the root of x. In other words, I multiply top by root x. And if you multiply the bottom by root x, what would you get? 2x. And then you get x plus 4 squared. If you prefer that answer, you can. This is also a good answer, by the way. I would say that the further you go into mathematics, the more lax we are about rationalizing the denominators. All right, thank you.